This video is about Coriolis effect. We all know that Coriolis effect plays a very important role in Earth's air circulation and formation of cyclones and thunderstorms, right? So let us assume that this is Earth and there are 4 layers of atmosphere, that is troposphere, stratosphere, mesosphere and exosphere. Let us assume we are observing from a space station somewhere above the Earth, and we are seeing the North Pole and observing the angular acceleration of Earth and these layers. We all know that Earth has its own gravitational field and it pulls these layers of atmosphere with the different forces. Therefore, the gravitational pull due to Earth on layer 1, that is troposphere, is greater than gravitational pull on stratosphere and is greater than gravitational pull on mesosphere and is greater than gravitational pull on exosphere. Therefore, the angular velocity of these layers are different. That is, angular velocity of Earth's surface is greater than angular velocity of layer 1 and is greater than angular velocity of layer 2 is greater than angular velocity of layer 3 and is greater than angular velocity of layer 4. So most of you will be thinking about how the angular velocity of Earth is greater than angular velocity of these layers. I'll be explaining this with the help of density and gravitational pull of the Earth. We will not talk about the airflow due to temperature and pressure differences in the atmosphere. If we take them into account, the analysis and explanation of Coriolis effect will get very complicated and difficult. So let us assume that the air molecules are there in troposphere, stratosphere and these layers. These air molecules experience a gravitational pull due to Earth. The air molecules nearer to the Earth's surface are highly attracted toward the Earth's surface because as the radius decreases, the gravitational pull increases. So the air molecules in the troposphere are highly densely packed, have very much density of air molecules in troposphere, due to which there is a viscous phenomena in between the air molecules and the Earth's surface. We will study further this in fluid mechanics in the chapter of boundary layers. Let us assume that this is the Earth's surface and this is the first layer of air molecules at a distance of x tends to 0. So this layer and the air molecules of this layer try to move along with the Earth's surface because of the viscous and gravitational pull of the Earth's surface. As we move above the Earth's surface, as the height increases, the gravitational pull and the viscous forces between them decreases. The gravitational pull decreases because as the radius between two masses get increased, and the viscous force decreases because the density of the air molecule get decreased as we move away from the surface of the Earth. So there is a difference in velocity of the air molecules which result into the difference in angular velocity of these layers. So we are not applying or analyzing the Coriolis effect in this picture, because if we do so and analyze the forces of Coriolis force or Coriolis effect in this picture, the analysis would be very difficult because of the different angular velocity of these layers. So we'll be analyzing the Coriolis effect on a body in layer A, which is in between troposphere and mesosphere in the stratosphere and moving with angular velocity of omega A. So in the previous picture we have talked about the layers of the atmosphere. In this picture we will see how the Coriolis effect come into picture. So we have divided our Earth into 6 segments, which are divided by 5 lines. That is, first one is the Arctic center, which is around at 66° north, and Tropic of Cancer, equator, Tropic of Capricorn, and Antarctic center. So we will be doing our analysis at the Arctic circle, at the stratosphere sublayer A, which is moving with angular velocity omega A, as we have discussed in the previous diagram. In the previous picture, I have talked about the different layers of atmosphere. In this picture, we will be talking about the main the Coriolis effect and how it affects the circulation of the wind and why it comes into picture. So we all know that the circumference of the equator is much greater than the circumference of the Arctic Circle or Tropic of Cancer. From the data, the circumference of equator is 40,075 kilometer, and circumference of Tropic of Cancer or Tropic of Capricorn is 36,768 kilometer, and the circumference of Arctic Circle or Antarctic Circle is 17,602. Right. We all know that the Earth completes its rotation in 24 hours. Therefore, the time taken by the Earth to complete one rotation is 24 hours. So a person is standing here at the equatorial line, right? And if a person is standing here in the equatorial line, completes one rotation of the Earth in 24 hours by crossing or along the circumference of covering 40,075 kilometer, while the person is standing at the North Pole or the South Pole covers 24 hours and covers 0 kilometer in 24 hours. Therefore, the velocity of the person at the North Pole or the South Pole is equal to 0. That is, the velocity of the person at North Pole is 0, right? While the velocity of the person or the object at the equator is much greater than the velocity of the object at the Arctic Circle. We all know that speed is equal to distance upon time taken. So here the time is fixed to 24 hours. Both the person standing at the North Pole and the equator have to cover their respective distances in 24 hours. Therefore, the speed at the equator is much greater than speed at Tropic of Cancer, greater than speed at Arctic Center, and greater than velocity at North Pole, which is approximately equal to 0 kilometer per hour, right? So as we move away from the equator, the velocity gets decreased and gets minimum at the North Pole and the South Pole. This is the fundamental basic of the Coriolis force. So if we are talking about this layer, A layer in the stratosphere, as we discussed in the previous picture, if we fly an object in this layer from equator to Arctic center in this direction, hope you are understanding this in 3D. So for example, if something is fly away from equator in a perpendicular direction, right? So this would be the intended path of the object moving in the sublayer A, but the velocity of points at the Arctic Circle is much lesser than the velocity of the point at the equator. So the object is observed to move right, because in that time this point has moved a very large distance as compared to that point which is the destination of the object. Therefore, if the object is assumed to land here, it would have landed somewhere else in the rightward direction, because there is a difference between the velocity of the points of the Arctic Circle and the equator. Similarly, in the southern hemisphere, if we fly an object in that layer in downward direction, the object will tend to move toward this direction. We all are told that just remember that in northern hemisphere the object will move toward right, and in southern hemisphere the object will move away toward left. So this is the proper explanation why this is happening. Similarly, if we throw an object from Arctic Circle in sublayer A, it would tend to move leftwards. It will move rightwards. Okay. So the maximum deflection will be at the North Pole. Maximum deflection will be at the North Pole and the South Pole, because there is a much difference between the velocity of the points between equator and North Pole and the South Pole. In the previous picture we have discussed about the Coriolis effect, how it deflect the moving object to the right in the northern hemisphere and deflect it to the left in the southern hemisphere. In this picture we will do analysis on that object moving in that sublayer that we have discussed in the previous pictures. Let us assume a two-dimensional figure of Earth and assume it as a disk which is rotating in anti-clockwise direction with angular velocity omega. So the omega vector is in k cap direction, that is out of the paper. So the angular velocity omega vector is equal to omega k cap, and we are observing this phenomena from Earth, that which we have assumed to be the frame of reference. We are standing on the Earth's surface which is rotating in anti-clockwise direction. So the object in that sublayer that we have discussed in the previous picture was observed to move in clockwise direction. We assume Earth as initial frame of reference, so the object in that sublayer would move in clockwise direction with a velocity of v. Okay, so the real forces will be get equal to 0 because the particle is assumed to be in inertial frame of reference. The particle is assumed to be in inertial frame. We know that we cannot apply Newton's law in accelerating reference frames, so we need correction factors. That is, correction factors are pseudo forces or inertial forces. Pseudo forces and inertial forces are centripetal, centrifugal, and Coriolis force that we are going to discuss in this video. Right. Now applying the Newton's second law on mass m. Applying Newton's second law on mass m. So MA vector is equal to the net force, which will be equal to the summation of the real forces and the pseudo forces. Because we are talking about a rotating frame, therefore pseudo forces need to come into picture, and the real forces are equal to 0, because we have assumed that the particle is in inertial frame. Okay, so if we are not talk about the Coriolis force, there would be centrifugal force would be acting radially outward in that direction, in plus r cap direction, right? And this acceleration a would be equal to omega square r in the negative direction, omega square r in negative r cap direction. Therefore this equation will be m omega square r minus r cap in minus r cap direction is equal to m omega square r cap direction, which is centrifugal force, and but this does not satisfy the equation, so we need more pseudo forces to justify Newton's second law of motion. So just adding some new forces, that is, if we add minus 2m omega square r cap into the picture, the Newton's second law of motion gets satisfied. Okay, so if we look at the picture and analyze the object m, which is rotating with the angular velocity omega having a linear velocity v vector. If we do a cross product of omega vector and v vector, we will get, which is omega is in k cap direction, that is omega k cap cross v is equal to omega r. V is equal to omega r, we all know that, which is in plus phi direction. Let us assuming this in plus phi direction and this is minus phi cap direction. So omega r in plus phi cap direction. So this is omega square r k cap cross phi cap, and k cap cross phi cap will be in plus r cap direction, omega square r cap direction. So we will be using this at this, so which will be equal to minus 2m omega cross v. This is known as Coriolis force, and this part 2 into omega vector cross v vector is known as Coriolis acceleration. Coriolis acceleration, which is denoted by AC. You will learn about Coriolis acceleration in theory of machines and mechanical engineering in detail, and this is it. We have analyzed it and learned about Coriolis effect and Coriolis force. Thank you very much.